Alright, so we're going to continue on with SSS, SAS, or ASA. And here I think you can see we have these two sides. So then these two sides, and of course the matching angle in the middle. So this is clearly side angle side right here. This is the one I would choose because basically those two angles are the same in these two sides, and that's the included angle between two sides. Alright, continuing to take a look at this one here. Same idea. We have two triangles. Now here, notice that this side right here in the center, this one right there, that side right here in the center is going to be congruent to itself all the way across. So this triangle and this triangle are the same by clearly side, side, side here, because those sides match, and that's part of the same triangle, but it's the same side. So there you have it. Alright, now notice that these are parallel here, these AB and CD, which means that this angle here and this angle here are the same. We also know that this angle here and this angle here are the same because of what we know about the triangles, the alternate interiors of two parallel lines. We do know this angle is the same, but angle, angle, angle isn't one of our choices. But notice this side is, and that's an angle, a side, and an angle. So we're looking at this one right here, which says ASA. Did I say that? Yes. Angle, side, angle. Angle, side, angle. Okay, here we're going to find a perimeter. This is a piece of cake. Basically, just add up all the sides around. 9 and 9 make 18. That's going to be 21 or 24. That's pretty clear here. Just add them all up and you get 24 centimeters. Make sure you put centimeters. That's for just adding them all the way around. Alright, we're going to find the perimeter again. We'll just have to do a couple things here. We'll notice that this one is 8. I know it's not drawn to scale. 8 and 12. So that means we have 20 across the bottom down here because we're going to see that this is going to be the same length here as this one and that one. So 8 plus 12. That's how I get 20 down here. That's going to be 20. And then 10 and 8. This side is going to be 18. So if we put those in there, and we'll just add all those three numbers or whatever numbers there is. We got 18. We got plus 20, plus 8, plus another 8, plus a 12, and then plus a 10. It looks like I got everything there. Well, it's funny as 10. It looks like a 10. Just add all those up and see what they are. Okay, and I ended up with 76. Okay, this was a little weird. We have to write an algebraic expression, but notice these are equilateral triangles. That means they're all 2b, and this is a square. So we have 1, 2, 3, 4, 5, 6, or 6 times 2b. You could also do 2b, 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 2b. I would think 6 would be better though, right? 1, 2, 3, 4, 5, 6. Notice it says the perimeter, and that we don't include these right here. This one and this one do not get included for the perimeter. So it's 1, 2, 3, 4, 5, 6, and all of them are 2b. So if you wanted to finish that up, 12b. Okay, it says to find the sum of the measures of the angles, that's a lot of ofs, of the measures of the angles of a 20-sided polygon. Sorry about that. Basically, just put 20 in for n, so the formula tells you right there that it's going to be 20 minus, let's see, so 20 minus 2 times 180. And whatever that turns out to be is going to be our answer. So I ended up with 3,240 degrees. Alright, for this one it says find the measure. Okay, so we're going to find the measure of angle A. Notice it's a 6-sided figure, so we'll use the formula n minus 2 times 180. So 6 minus 2 becomes 4 times 180. So we have 4 times 180. It turns out to be 720. And then we're going to divide that by 6 to see what the angle A is. That turns out to be 120. And then let's see, if we do that, then we can know that B has to make a straight line. So this is angle A here, so angle B is going to be 180 minus 120, so that's going to be equal to 60. Alright, taking a look here, we find the sum of the measures of the angles of the figure. Well, we can see here that we have 1, 2, 3, 4, 5-sided figure, so we'll take 5 sides here. Right, we have a 5-sided figure, so 5 minus 2 times 180 is going to be 3 times 180, and that's what we're going to do to figure out what angle A is. So we know the whole thing adds up to be 540. Of course, we need to subtract away the 90 and then another 90 and then C subtract away a 160, and then subtract away a 40, and whatever's left over, that's going to be angle A. So that turns out to be 160 as well. So we have here 160. Coincidence that it's the same as the one above it. All right, find the measures of angle A and B, and B would therefore be equal to 20. For the angle B, you're going to have 20 because together they have to make 180 degrees. Okay, so our goal is to find the measure of angle 1. What we can do here is we can see that we have, well, to figure out this angle right inside here, we have to figure out what 180 minus 63 is. So if I draw a line through here, out there, so that would be 180 minus 63. So 117. Okay, we also have a 1, 2, 3, 4, 5-sided figure, so 5 minus 2 times 180 tells me that the whole thing has to add up to be 540. We also know this angle here has to be 180, so we're looking at 85. All right, so then we just have to add those up. So let's come over here and do this. We'll have 540, and we're going to take away the 143. We're going to take away the 85. We're going to take away the 117. And then we're going to take away the 140. And then we'll see what's left. And I get 55 degrees is my answer. So that's the answer for this problem right there. Okay, so for this one we need to figure out this missing side. So we have that 4 squared plus, if you want to call this side x, x squared has to be equal to 5 squared, or 16 plus x squared is equal to 25, which means x squared is equal to 9, or x is equal to 3. So if x here is equal to 3, then the area, which is 1/2 base times height, becomes 1/2 3 times 4, or 1/2 of 12, which is 6. And then don't forget to put inches squared. And there's your answer right there. All right, we're going to use the formula for a parallelogram here. This is a parallelogram. To see that it's basically the height, the area, is going to be the base times the height, or 41 times 31, whatever that turns out to be. Turns out to be 1271 centimeters squared. Notice I did not use the 37, I used the height, because a parallelogram, if you look at the formula, is the base times the height. Okay, the area of a circle and the circumference, a couple formulas you should know. Circumference is equal to 2 pi times the radius, and the area is equal to pi times the radius squared. So here we have 2 pi times the radius of 2 equals to 4 pi. Okay, and then pi r squared would be 4 times, well, 2 squared, which is also 4 pi. So here they're the same, coincidentally, by the way. And then to find it rounded to the nearest tenth, just do 4 times 3.14 to see what that is, rounded to the nearest tenth. Okay, so when you get that, it's 12.56. To round to the nearest tenth, though, is 12.6. Okay, circumference and area of this circle, we just did something like that. So let's take a look at what we can do here. First of all, let's note that the radius this time here, radius is equal to 8, half of that 16. Remember, the radius is only this half right here. Don't forget that. That's the radius right there. Okay, express the, find the circumference and the area. So circumference will be, capital C is equal to 2 pi r, which in this case will be 2 pi times 8, or 16 pi. And the area will be equal to pi times the radius squared, or 64 pi. Okay, and there's your answers in terms of pi. And then just put in 3.14 and round them to get to the nearest tenth. Okay, notice that this is a square, and then that's a diameter of a circle, and 2 of them. So the first part is we have a square. So for the first part here, I'll just say we can do, for first part here, we'll do 14 squared to get the area all the way inside there. And then we have 1, 2 circles. So for the second part, we're going to take the circle, which has a radius of 7. Notice it's half of that. So we get pi times 7 squared, or 49 pi. Of course, that's for one circle, and we have 2 of those, so we're going to want to multiply those by 2. So 2 times 49 pi is 98 pi. Okay, so what we have here is 98 pi plus 14 squared. So for our total answer, we're going to have 14 squared, which is 196, that's 14 squared, plus 98 times pi. So when we finish this, 146 plus 98 times 3.14, let's see what we can get out of that. All right, and after we multiply that out, we have 503.72, which rounds to 503.7. Okay, and for us to finish this up here, homework 7, last one, we want to find the shaded area. Well, the full area inside that circle, we first need to do the Pythagorean theorem. We're going to call this x for a minute. So here's x. So we can say x squared equals 18 squared plus 24 squared using the Pythagorean theorem. So x squared is going to be equal to, okay, so 18 squared is 324, 14 squared is 576, sorry, 24 squared, not 14, 24, that's a 2. That adds it to be 900, which is telling me that x right here is equal to 30, because the square root of 900 is 30. So we know this is 30, which tells me that we have a radius of 15. So the area of the whole thing is going to be pi times the radius squared. So we have 225 pi at the moment, but that's everything. And then we can take that and we can subtract away the area of this triangle, which is the area of the triangle, remember, is area equals 1/2 BH. So 1/2 BH becomes equal to, let's see, 18 times 24 divided by 2, which is 216. Right, so we have 18 times 24 divided by 2, that's a 2, and then we end up with 216 in there. So this part in here is 216, and the whole thing's 225 pi, so we want to take out that 216, and then we'll go ahead and figure that out, and we'll get 3.14 times 225 is 706.5, and then subtract the 216, so we get 490.5. Okay, good luck on homework 7.